For number 6, we're dealing here with matched pair data or dependent samples. So you can see there are two samples. We're calling one our X sample and one our Y, and there's pairs here between each of the samples, and you can see which data in each set is paired with data in the other set. So when we try to see if there's differences between dependent paired samples like this, we need to start by finding the differences between the X's and the Y's that are paired together. So that's all we're doing here is subtracting the subtracting the values. So you would take one of the values in the first set and subtract away the value that it's paired with in the second sample, and you get that difference. And then you do the mean, the average of those differences, and the standard deviation of those differences. Now, you can work those out quickly using StatCrunch, and I'm going to show how to do that. So you want to take that data, and the easiest way to get it in StatCrunch is to copy it to the clipboard. Let me just start over here, and we will paste it. And we're going to go to Stat, our T-stats with paired data. And so notice where the data was. That first column, the X column, was in variable 2, var 2, and the Y sample was in var 3. So I'm going to select those for where sample 1 is and where sample 2 is. var 2 is the X's and var 3 is the Y. And I'm going to want to save the differences. That's going to do all those calculations that I needed here in part A, those differences. It'll show me what all of those are if I click Save Differences. And then I'm going to go ahead and set this up based on what we're looking for. Part C says test if the differences are less than 0. So that means I'm going to do a less than here, and I'm going to hit Compute. And so I get some solutions here. I get the p-value back, the test statistic. I get the mean here is what you want to put in for part B, the mean of the differences. And there's that p-value that I showed as well that comes up. Now what you don't see coming up here is the standard deviation of those differences. What you need to do if you want to continue using StatCrunch for that, you go to Stat, and then Summary Stats on that column where the differences are. And by default, the summary stats include all the stuff listed here in the white box, which part of it is standard deviation. So if I just hit Compute, I get all that summary stats from the differences column, and that standard deviation is what I want for this S sub D right here. That was part of part B. All right, so I have my null and my alternative. Our null is always equality. We're assuming there's no difference, and it told us what the alternative is. And I showed how to get that p-value. And now that p-value, 0.02, it's less than our alpha, which means we have enough evidence to reject the null hypothesis. And that's what we're going to select here. There is sufficient evidence that the difference is actually less than 0. And to wrap up, we're going to do a confidence interval. So you can actually pull that back up in StatCrunch where we were, the summary stats. Oh, that's the wrong one. It was our paired hypothesis test here. I can go back and edit it, and instead of checking hypothesis test, I'm just going to do confidence interval, and it was 95%. I was checking to make sure I have that right. Hit Compute, and you get your lower and your upper limit. And you would want to enter those there. And you can see that these correspond and give the same result as we got from our p-value approach hypothesis test. This said there was sufficient evidence to reject that the null was true, that the difference could be 0. The confidence interval also gives us evidence to reject that the difference is 0, because 0 is not within this interval. The lower and upper bound are both negative, so 0 is not in between it. So 0 is not a good conclusion, so we would reject the null hypothesis. For number 7, we have more matched paired data, and you can read about why this example is matched paired data is because we're firing a gun, and each time we fire it, we're taking 2 measurements on that same round that was fired. So those 2 measurements would be paired together because they're 2 different devices measuring the same exact shot of the gun. So we have matched paired. We would want to copy that to the clipboard and open it in StatCrunch. I'm going to paste it here. Now, some of you might have success just clicking on the Open in StatCrunch button. I was having a little trouble getting that to work, so I'm using copy and paste. But once we've pasted it and got it in StatCrunch, we're going to run a hypothesis test at this significance level, 0.01. And we're just trying to see if there's any difference between the measurements coming out of device A and device B, these 2 samples. So our null is that there's no difference, equal to 0. Our alternative will be that there is a difference, so not equal to. So getting back into StatCrunch, I want to go to Stat, T-stats paired. And again, my 2 devices were in columns 2 and 3, so I want to select that. And I'm doing a hypothesis test. I hit compute, and I get my p-value here, 0.3275. And I also got that test statistic. So enter those in. Now this is quite a bit larger than our significance level, and since it's bigger, we do not have enough evidence to reject the null hypothesis, and that's what we're going to fill in here. Now we're going to construct a confidence interval, and we can go to Options, Edit, and just change it to confidence interval. And I forgot to check my level of confidence is 99%, so I'm going to change that to 0.99. And you get your lower and upper limit. Now notice how 0 is in between these values. One's negative and one's positive, so 0 is in between. And that again just kind of matches what we saw from our hypothesis test, that we don't have enough evidence to reject the null that the difference is equal to 0, because 0 is within our 99% confidence interval. And so that's our interpretation here, that our mean difference lies somewhere within this interval, 99% confident of that. Now the last part here wants us to draw a box plot of the data, and one of the options we had filling this out, you can actually come down here and tell it to draw a box plot with the mean marker. So I'm going to actually select that and hit compute. And so you get that same typical table you see, but up at top it says 1 of 2. And if you click over at the bottom, you'll see the box plot. And so this is what we were looking for, and you're going to find the one that matches that. Look for where the mean is drawn above. So looks like it's just below -1, and a very short tail on the right side and a long tail on the left that goes to about -9. So that's what I'm seeing here. And I misspoke there. This is the mean. This is the median. In a box plot, the line in the middle of the box is the median, the middle value. And so find the one that matches that. And in this case, it would be number B here, letter B. And in that interpretation I kind of already talked about, does the evidence support the results that we got in our hypothesis test? And the answer is yes, because 0 is within our box plot here. For number 8, we have another dependent situation. We're testing whether fathers, we're testing the belief that sons are taller than their fathers. And so we have paired data here. Each son is paired up with the father from the 2 samples. and we have a dependent situation. And so these are the criteria that need to be met for us to do our hypothesis test. And our null hypothesis is always that there is no difference. So we're going to say that our sample, or our populations here of the mean height of fathers and mean height of sons, that there's no difference between them. So their difference is equal to 0. And then our alternative here is a less than. So if the sons are taller, then we would expect this subtraction, this difference, to result in values less than 0, because the heights of the sons would be bigger than the heights of the fathers. So with our null and our alternative, let's open that up in StatCrunch. And I'm going to go to stat, tstats, paired, and then height of the father is my first sample, height of the son is the second, and I'm doing a less than. So when I compute that, I'll get my test statistic, I'll get my p-value, and since that p-value, our alpha was 0.01, that's quite a bit larger than that. Like with all hypothesis tests, that means we do not have enough evidence to reject the null hypothesis. And so in our context here, it means there's not sufficient evidence to accept the alternative, which was that the sons are taller than their fathers. For number 9 here, we have another dependent situation. We're testing the same piece of metal with 2 different methods. And so each piece of metal that's being tested creates this pairing of data between the 2 samples. And we're trying to see if these methods produce any different results in testing the hardness of the metal. So we're going to open this in StatCrunch here. And what we're looking for is a 95% confidence interval for the difference of these 2 methods to test the steel, or the metal. And notice what it says here, the differences are computed as diamond minus steel. So when I go here in StatCrunch, my t-stats paired, I want to do diamond as my sample 1 and the steel method as sample 2, because I'm StatCrunch does sample 1 minus sample 2. And you can see that here, U1, the mean of sample 1 minus the mean of sample 2. And so make sure you have those in the correct order. Select the correct confidence level, and when you hit compute, you'll get the lower and the upper limit. And so round those to the nearest tenth, and you'll see that 0 is not in this confidence interval. So the assumption that there's no difference, which would produce a difference of 0, should be rejected. So there is sufficient evidence to conclude that the 2 indenters, the steel ball and the diamond, produce different hardness readings. And that's because our confidence interval does not contain 0.